All right, let's talk about dark matter. What if this huge mystery, one of the biggest in all of science, isn't what we've been told it is? Today, we're going to dig into a pretty wild idea from our source material that suggests we might be on a hunt for something that, well, was never even there to begin with.
Okay, so to get a handle on this, you gotta understand just how massive this problem is. Look at this. Everything we see, everything we know and can touch, stars, planets, you, me, all of it, that's less than 5% of the entire universe. The other 95%? That's the dark stuff. Dark matter and dark energy. Stuff we can't see, and let's be honest, we just can't explain. So to really get why this is such a head-scratcher for physicists, we first need a quick look at the current rulebook for the universe, what they call the Standard Model of Cosmology. The way our sources explain it is actually pretty cool. Think of all of reality as a big stage play. According to Einstein's general relativity, you've got two main components. First, there's space-time itself. That's the stage. And then you have all the energy and matter, which are like the actors moving around on that stage. And this is where it all comes together, in this famous equation. It looks complicated, but the idea is simple. The right side, that's the energy, our actors, is basically telling the left side, the geometry of space-time, our stage, how to bend and curve. And that bending and curving, that's what we feel as gravity. But here's where the story gets a twist. Astronomers started looking at galaxies, and they saw them spinning so fast they should have literally just flown apart. The gravity from all the visible actors, the stars and gas we could see, just wasn't strong enough to hold them together. So, to make the math work, they had to invent a new invisible actor. And that kicked off one of the biggest searches in scientific history. And the leading theory, the one that really took hold, was that this invisible actor is a new kind of particle, a dark matter particle. It's something that's not in our current standard model of physics, but it's out there, on the right side of Einstein's equation, providing all that extra gravity we need. We just can't see it. And believe me, this wasn't just some casual guess. We're talking decades of work, a massive global effort. Billions, with a B of dollars, have been poured into building these unbelievably sensitive experiments, usually deep underground to shield them from interference, all for one single goal: to catch just one of these elusive particles. So after all that time, all that money, all that human ingenuity, what have we found? Absolutely nothing. Zero. Not a single clear, direct detection of a dark matter particle. It's been a complete blank. And this is where things get really, really interesting. The source material points out something crucial. This isn't just a small failure. This persistent failure, as they put it, is so profound that it justifies questioning the entire idea. Maybe we don't just need a bigger, better detector. Maybe we've been asking the wrong question entirely. And that brings us to a truly mind-bending pivot in the source material. What if we've been thinking about the universe completely backwards? What if the problem isn't a missing actor, but the fact that we separated the actor from the stage in the first place? So, instead of a universe with two separate things, space-time and energy, this new idea proposes there's only one thing, a single, unified, and get this, elastic fabric of reality. In this view, the line between the stage and the actors, it just disappears. Now, that word elastic is the key to the whole thing. This is what's called intrinsic elasticity. See, in the old model, space-time only bends because matter and energy tell it to. But in this new model, the fabric of reality can warp and wave all on its own. It's an inherent property. Think of it like a giant trampoline. It can ripple and move without anything needing to jump on it. Okay, so if dark matter isn't a particle, if it's not an actor on the right side of that equation, then what's causing all that extra gravity we see?
Well, the source argues we've been looking on the wrong side of the equal sign this whole time.
According to this new framework, what we call dark matter isn't matter at all. It's a purely geometric effect. It's just big, slow-moving waves or wrinkles in the fabric of reality itself. We're not talking about the kind of fast gravitational waves we've detected from black holes merging. No, these are much, much larger. And because of their complex shape, they actually travel slower than the speed of light. And if this is true, wow, the implications are just enormous. This doesn't just potentially solve the dark matter mystery. It forces us to look at everything else we thought we knew about the cosmos through a completely new lens.
I mean, take dark energy, for example. The whole reason we think the universe's expansion is accelerating is because of how we interpret redshift, the way light from far-off galaxies gets stretched. But our source material points out that this new elastic fabric model could explain that same data in a bunch of other ways. Maybe the speed of light isn't constant, or maybe our distance measurements are more dynamic. The bottom line is dark energy might not even be necessary anymore.
So it all comes down to this really challenging question, doesn't it? Is this decades-long, multi-billion-dollar hunt for a missing particle actually a hunt for a ghost? What if the missing mass we've been searching for was never a missing actor at all, but was just the gentle, slow waving of the stage itself? I'll leave you with that to chew on.